in this problem, we're giving a rate of change for the number of mosquitoes on the tropical island, and here's the equation for the rate of change, mosquitoes per day. So that's really a rate or a derivative, and assume that this is an initial condition that at t equals 0, there are 1,000 mosquitoes. It says show that the number of mosquitoes is increasing. This is already a rate, so they're trying to trick you into thinking that you need to take the derivative. But what you need to do is you just need to plug in 6 into this problem, and this is going to be calculator work, and you can show that if you plug in 6, you can show that this is a positive number, meaning that it's increasing because r of 6 is greater than 0. Okay, so it's a positive rate of increase in mosquitoes per day. Part B says, is the number of mosquitoes increasing at an increasing rate, okay, or increasing at a decreasing rate? We know that it's increasing at 6 already from part A, so basically what it's asking us to do is to find the derivative. So what you have to calculate is you have to calculate r prime, which is the rate of change of the rate of change, and plug in 6. Again, this is calculator work, so you can use n derive. If you check the answers, it looks like negative 1.913 or something like that. The point being it's less than 0 or negative, so it's actually decreasing. Okay, and again, because the rate of change is negative. The rate of change of the rate of change is negative. Okay, part C, according to the model, how many mosquitoes will be in the island at t equals 31? Since you know this is a rate, you're probably going to integrate r of t dt, and we're going to integrate from t equals 0 to t equals 31. Okay, so we don't really know what that's going to be. That's all calculator work. So we'll just call this the number of mosquitoes, but keep in mind, by the first fundamental theorem, it's going to be the number of mosquitoes at 31 minus the number of mosquitoes at 0. What we know is that there is 1,000 mosquitoes at t equals 0, so this is 1,000. Okay, so what ends up happening is we're going to take the 1,000 on this side, because we're going to add it to both sides, because right now it's minus, plus the integral, which you're just going to have to do on the calculator, r of t dt, and that's going to be approximately 964.335 if you work it out correctly on the calculator. Next part says in the nearest whole number, what is the maximum number of mosquitoes from t equals 0 to 31? Show the analysis. This is going to be the hard part, the analysis. Okay, so see the word maximum, so I got to think derivative, but keep in mind this is already a derivative. So what we're going to do is we're just going to set r of t equals to 0, and that's going to give us our critical numbers. The best way to do this is probably to graph it on the calculator and figure out where the graph hits 0 and use the 0 function on the calculator. Okay, so we're going to look at the graph. Here it is on the graphing calculator. Notice there are some critical numbers. There's actually going to be, well, there's an endpoint there, which might be a max. There's a critical number there, and there's a critical number there. So remember, the endpoints are 0 and 30. Those have to be considered. Okay, keep in mind this is r, which is already a derivative. And there were two other critical numbers. It turns out there, you can do this on the calculator or do it by hand. It's going to occur 2.5 pi and 7.5 pi. Okay, or I could have just used the 0 function on the calculator to figure that out. If you remember what the graph looks like, it goes positive, then negative, then positive. Up, down, up. Okay, so I'm going to graph that over here. It's going to go positive, negative, positive. So we know it went uphill, then downhill, then uphill. Okay, so the only possible places where I have a max, I might have a max here, I might have a max here, and I might have a max here. It's really hard to tell. Okay, this one I already know at the initial there's 1,000. Okay, to figure out a 2.5 pi, I actually have to do the integral. So keep in mind, I had 1,000 plus, now I got to add the integral. Okay, let me move this over here, because this is going to take up too much space. Okay, I'm going to integrate from 0 to 2.5 pi r of t dt. Okay, it turns out that's approximately, it's roughly 1,040 mosquitoes. So already, this is already bigger than the other one. To figure it out here, I need to do the integral from 0 all the way to 31 r of t dt, which turns out to be 964. So it turns out that this one wins.